Now we're going to turn from expected value to present value. We need to define a few terms before we can really start discussing the concepts. Present value, which we will denote by PV, is something's current worth. Now this could take on two different meanings. First of all, present value could be money that you have right now that you could put into a bank and earn interest on. Or present value could refer to the fact that you're going to get a payoff in the future. You don't have the money now, but you will be getting it in the future. And in that case, present value is how much you value that future payoff today. The interest rate, which we'll denote as R, is the risk-free rate of return that you could earn on your money. Now, this brings up sort of an interesting side question, which is there such a thing as a risk-free rate of return? Up until recently, most economists would tell you, well, yes, something like a U.S. Treasury bond would be a risk-free instrument. And so if you bought one of those bonds, you would be guaranteed whatever interest rate it was paying. In recent years, that's become more questionable. It's not entirely clear that the U.S. government will be able to live up to all of its debt obligations, but U.S. Treasuries are still extremely safe, and the probability of default is quite low. And so for the purposes of this lecture, we will assume that there is a risk-free rate of return that you could earn on your money. The duration, which we will call T, is the number of time periods that you have to receive interest on your money. We will count T as the number of years that you can earn interest, and we're going to assume that the interest is paid at the end of each year. In other words, it's not compounding monthly. In reality, of course, interest typically compounds at a monthly rate, not at an annual rate, but assuming an annual compounding of interest allows our calculations to be simpler. Finally, we have future value, which we denote as FV. That is money that you will have after T time periods or T years. It's actually easier to understand present value calculations if we first understand future value calculations. So let's take the following simple scenario. Imagine that I have a $100 bill and I can put it in the bank at a 5% annual interest rate. And again, we're going to assume that interest compounds annually. It accrues at the end of each year. How much money would I have at the end of 3 years? Well, that's a fairly simple calculation. First, we just take that $100, and in year 1, I'm going to earn 5% interest on it, so I'm going to multiply that $100 by 1.05. That gives me $105. In year 2, I'm going to start with the $105 that I had at the end of year 1, and I'm going to earn another 5% interest on this money, and so I multiply the 105 by 1.05 again, and that gives me $110.25. And in year 3, I will start the year with $110.25. I earn 5% on that money, and so I multiply it by 1.05, and that gives me $115.76. Now that's a fairly long way of calculating the future value of my current $100. I could do the same calculation in just one step, and that would be to take the $100 and simply multiply it by 1.05 3 times. Now those 1.05 terms, we can collect them together into a single term, and we can see that the future value of my $100 is going to be 100 times 1.05 to the power of 3. That means that in this specific case, the future value is given by 100 times 1.05 cubed. And notice that now we can go from this specific case to the more general case. So what is that $100? Well, that $100 is my present value. It's the money that I have right now that I can set aside to earn interest. What is the 1.05? Well, that's just 1 plus the interest rate. And that cube term, that 3, is just the number of time periods that I will be collecting interest. So in general, that is simply T. That means that in general terms, our future value formula is given by the following. Future value is equal to present value times 1 plus the interest rate to the power of T. Now that we know the future value formula, we can easily find the present value formula. Future value is equal to present value times 1 plus R to the power of t. If we want to find the present value from that formula, we can just divide both sides of that equation by 1 plus r to the t, and we find that present value is equal to future value divided by 1 plus the interest rate to the power of t. The present value formula tells us how much money we would have to set aside today to get a certain payoff in t time periods, given that we have an interest rate of r. That turns out to be equivalent to the amount that we should value today a given payoff that will come t time periods in the future, assuming that we have that same interest rate. Why is that? Well, suppose that the interest rate was 5% and someone offered you a bond that would pay $115.76 in 3 years, and he wanted you to pay him $105 for that bond. Should you accept? Remember that we know that the present value of that bond is $100. So why is that $100 the most we should be willing to pay for the bond? Well, think of it this way. You essentially have two options. The first option is you give this man $105 today, and in 3 years the bond that you receive will pay you $115.76. Your second option, though, is to just deposit $100 in the bank and allow it to collect interest there for 3 years. At the end of that 3 years, your $100 would have grown into $115.76. Now, if you put your money in the bank, you get the same future value, but you have that $5 left that you can spend on something else. The essential point is that you shouldn't pay more for a future payoff than it would cost you to create that future payoff on your own.